So you don't like things to try. Okay, so first off, you may remember that we've been looking a lot at things that help us create a project question. Do you remember what those two things are? Yes?
The independent and dependent.
Independent, dependent variable. Very good. So I would like for you to please look at this example. This is an example that you could see tomorrow on your quiz. How can we come up with a project question here? As Jessica said, the first step is, what is that independent variable? What is the thing that I change? Very good. All right, Connor.
Drops of fertilizer.
What about the drops of fertilizer? You are correct. You're on the right track.
It's the dependent variable.
Independent variable. So drops of fertilizer. We need units. The only thing missing is units. Okay. You could have one drop of fertilizer. You could have 2 drops of fertilizer. So all you need is the number sign. That's it. Number of drops of fertilizer. Excellent. Where would that go on a graph? If I was making a graph, where would I put that?
The x-axis.
On the x-axis. Very good. Down at the bottom. So drops of fert in numbers, or number of drops of fertilizer, something like that. And then, what's next step? I'm still down here, though. Morgan?
The amount.
I got to put the amounts there. So,
0,
0, 2,
2,
4, 6, 8, boom, 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 boom. And I know Lang would want you to put an X there. Good job. Now, what comes next? Oh my goodness, Sarah.
Wouldn't the y-axis be the height of the plant?
Y-axis. Height. Plant. In inches. Which is funny because it's in. Height of plant in. Okay, keep going. Sarah?
Oh, and then maybe you could do like 0 inches and then go up by 2. So 0.
2, 4, 6, 8. Maybe we could look at the maximum height or average height of this particular plant, and that might give us our range over here. Awesome, awesome. Now, could somebody take this or that, or one of the two, and come up with a project question? Oh my gosh, this is hard to decide, because they're all sitting at the same table. Jessica has raised her hand more frequently than I think the other 2 people. Go.
Me? Oh! If I change the number of drops, or question. Wait.
You began a hypothesis. Excellent self-examination. Keep going.
When I change the number, how does changing the number of drops of fertilizer affect on the plant?
Affect. What is the change that we're trying to measure?
Height of the plant.
Height of the plant. How does changing the number of fertilizer drops applied affect the height of a plant?
In inches.
In inches. In inches. Raise your hand if you think you can do this tomorrow. I think I can get a picture like that and do these things. That's kind of what we're looking for.
Same picture?
No. No. Can't give you the exact same picture. But maybe we could have something like this, you know? You know, you have the graph. Could you come up with a project question for it? These are the types of steps that we're moving towards for tomorrow. Yes, ma'am?
Can you reinforce some of the concepts from the presentation?
Yes. Yes, absolutely. We will move on to that here in a moment. For any other questions with what I just did with the introduction? Taking a graph and turning it into a project question, or taking a question, putting it into a graph. The important 2 concepts are the independent and dependent variables. Very good. All right. So now, let's look on the back of your center angle and day length inquiry on the back. So mentioned reinforcing some of the concepts. That's kind of what we're doing right here. So you got to already have the graphs that you have made. You made 2 graphs for these. You might even be able to identify which one of these 2 graphs on the back you've already made. One of these graphs on the back is new. One of these graphs on the back is something that you have already done. You have already created one of these graphs. So this is graph A, this is graph B, and I put your latitudes over here for this one. Yes, sir?
You already created A.
How'd you know?
Because I did it. On this.
Okay, so I'm seeing 300, 400, 500, 600. Is the dependent variable on either one of your graphs in hundreds?
No.
No. Interesting. So, we may or may not know exactly what we're looking for here. So, we notice we have 7, 8, 9, 10, 11, 12, things like that. 1, 2, 3, 4, 5, 6 different questions. Number 7 is pretty involved. That's probably a one-person job. The rest of them, we should divide amongst our members at our team. And Sydney, sorry to mess things up for you today. You're going to join Sarah's group. So now we have a bit more equal groups around the room. So not every day, but today, see a bunch of people are gone. We're having to adjust a little bit. So your job as a team is to divide the labor, knowing that number 7 is a one-person job. You might have somebody else do 2 or 1 or things like that. So you're deciding as a team, which ones am I going to do here? And after you're done, and after maybe a minute or so of you talking with your group, we want you to silently finish your part, and eventually we'll put the pieces back together again. Questions? Go.
This one is 18, so
7 different things.
10 we already did, kind of.
We want to do what?
No, it was on like
Let me give you a compliment.
be together.
You labeled each of these lines with their location. That's a good thing. Was our variable their location?
Okay, so I'll do 7, then
Latitude.
I'll do
13 is number 8.
It's going to make a difference when you start comparing with these, right? To know that Alaska is 60 degrees latitude will help you connect these better. Make sense? Okay, sorry, keep dividing.
You know, the remaining 10, 11, 12, 13.
I'll do
So we all do 7. So you'll do 13. Wait, so you say you're doing 8, 9, and 10.
yeah, so there's no way we have to go back.
9, 10, 11.
What, there's 6 questions. No, are you guys not counting out?
Dividing the labor.
I got you.
One person to do number 7.
We would really do the first doing it underneath that.
And everyone says they're doing 11 or something.
What each side represents for this, we don't even know what it is.
True, but for 9 you just have to, that's fine.
I'm saying 7.
Oh, you just haven't done. So to make sure that these don't get lost,
We're supposed to do that.
we tape them into our level. We tape these guys in, and we can use the back of our papers. In fact, you'll use half the resources, the natural resources. Use the back of your
Well, second graph is insane.
So you divided the labor.
Both graphs.
So now you're silently doing your part.
What each axis is explained.
No, I know, that's what I'm saying. But on the last graph, we can't.
Have you divided the labor? So now you're silently figuring out your part.
Oh, my can do 9.
Color each line in the graph to indicate their line.
So, is this one,
Colors.
so we would be using as sorry.
Well, mine was just label X and Y, and each one label.
It doesn't change very much, so I'm with it.
So we have several things that we've been looking at in this. investigation. Daily,
Like on the left.
sun angle, we don't know yet. Daily, sun angle, and we don't know yet. So speed, what are you concerned about why speed is part of this equation? Solar radiation, the amount of energy you're receiving from the power, that's solar radiation. What's our independent variable over here? Would it be a high, a low, or a medium? Those are our own options. See, 90, 60, 30, 0. Much nice.
Wouldn't it be go longer and then shorter maybe?
Oh, wait.
What are you working on?
Yes.
Solar radiation. See that heat you get from the sun. See anything in this graph that doesn't change here?
Direction.
Where's that?
Okay.
Well,
I got it. They didn't have the questions on the, they didn't have the X and Y, they didn't have the labels of the Y, and they didn't have the labels of the
The
Y.
latitude increases day length throughout the year.
you found a place to be here.
Equator is a straight line.
Did Ecuador change their energy?
They didn't really,
I think it might just be black and white.
This one's 65 and 80.
because we know that
Are they
it's
similar to both graphs?
latitude
The higher
And then they change the
of changing the latitude of location
solar
affecting
radiation doesn't
the higher
change
the
very
slope, the
much.
higher the light.
Can you tell me about them?
with the second one you're
I know, but we don't have four of them.
Like a higher or lower?
I'm just guessing. I'm guessing.
Zero, a big or small number.
you have something like that.
Okay, let's say 1 degree north or 1 degree south.
Yeah, but
Is that a large number?
Wait, isn't today taking south to work?
Maybe it's a large number. No, so it's not a high latitude or a low latitude. It's a low latitude. Question time. Have you individually tried to finish your part?
Yes.
Now would be the time to start asking questions of your teammates if you need to, or asking questions of me.
how are we supposed to figure out what's beside us?
That's right. Does it look similar to your other graphs?
Yeah.
No, it doesn't. You see how one place, which you
And also to see
will label here in a second, but yeah, we got 0 there. Doesn't change much. Doesn't change much. Doesn't change much. We have some consistencies with the equator, don't we? Now let's try and find some differences. What is the most extreme line? Yeah. It's a 12 degree sun angle. So this graph looks the same as this graph. Oh, this one doesn't have a title. I don't know what this graph is showing. Oh, it's showing sun angle. Are these the same graphs? No.
What units are being used?
Ah, see? Much better.
They did not label.
You had the easiest one.
Good correction. See, I can tell the difference between those graphs. Here you do see some intersections. Not a lot, but some. Do you see intersections here very much? 2, barely. Not much at all. So do you think this is the same as that? Not exactly. So here you have 60 degrees north. The scale's way off. Here you have Anchorage, 60 degrees north. Here's a line, blue line, which you can draw in, that is 60 degrees north.
I know, but that's what I'm trying to figure out.
Oh, I see. Not steep. More steep, even more steep, steepest. You see how there's a progression?
Okay,
Beautiful.
It's just
just we're trying to figure out what actually what goes on.
Exactly. And you're doing the same thing she's doing? Okay. Pretty good so far. Which one are you doing? Try as well. Questions? Right, so which one do you think is 0? In all of our other graphs, 0 stays the same. So which, probably the one that starts up at 400 and stays pretty much. So everybody doing your part?
Oh, no.
That would make sense.
Feeling a little better? Alright.
Okay, so
You're loving what's the why?
Does it look similar to the other two graphs you made?
Oh yeah, we're actually
He just told us that.
None of the big guys. Look at the equation. Up, down, and up, and down, and not change too much. This one just goes down and back.
So I accidentally should have looked at
Doesn't really change that stuff. Here, similar slope, right? Here, big change in slope, right? So if this is sun angle, and the other side is day length, doesn't have a title. Sun angle is day length. I mean, what might be another option for it?
Okay, 12. You guys all get 12? No? Okay, 12.
Oh, that's
Are you ready?
Sun angle on this graph, your day length on another.
Oh, oh, okay.
Alright guys, let's go.
Yeah.
Alright.
Thank you.
We've had a couple of groups ask me questions. We've had a couple people figure things out on their own. Share that with their group members. And then a few people share questions that they have, misunderstandings, I don't get it. So we're regrouping now. I wanted you to struggle a little bit, try some of these things out. Olivia is starting on top of the question.
Are we going over this?
Yes.
Okay, great.
Awesome. Alright, number 7. So table 9. Who had number 1? Or, oh gosh.
7.
Who had the first task? Number 7. Who in your group decided to try that?
Well, we all did.
That's what we did too. We thought 7 was everybody was supposed to do it, and then we each had a special
7 takes a lot. 7 is a one-person job.
Oh.
Did I say one-person job?
Yeah.
Thank you. Thank you, Connor. One-person job. Okay, so I guess I have to say anybody at table 9. Help us out with number 7. Give us one piece of information that is missing from these graphs. Go. Faith.
The x-axis is missing, like, it's covering months.
Aha, months. Months are a unit of time. So we got time in months. Is this the same for both or different? Same for both. Alright, next group. Table 3 in the back. What other things can we add here? Time and months.
Okay, well, for the one on the right, we know that it's day lengths for the y-axis, but we don't know about
Day length. Oh, in hours. Okay, in hours. Okay, that makes a difference. So we have our units there. How did you know that this was day length?
because it had the time and it resembled our graph on day.
It resembled the graph that you made, and the easiest way I think to find out if it's the same graph is to look at these special times called, anyone in the room? Equinoxes, where all of these lines come together, and the whole world has the same evening hours and the same daylight hours. They all have 12. It's all 12 right here. It's all the same for everybody. Even if you're at the North Pole or the equator, everybody has 12 hours of daylight and sunlight. Olivia.
You can also tell because it goes up to 24 hours.
You can also tell that it goes up to 24 hours. That would be one clue that possibly this is daylight in 24 hours. Excellent. So now we have this axis labeled. Moving on, next group, table 4. Who in your group was responsible for number 7? Tell us what you found, what you wrote.
So I also, for one of the things that was missing, they didn't have a
Beautiful. So that means that we may be able to put that title up. Is there a question number that can help us find those titles?
Maybe, how does, the month...
You're okay. Hold on just for a second. There is a number written on this page that can help you correspond to the title of each graph. There should be someone else in your group helping you out. Say, I know the title of each graph. Sarah, the title of all graphs begin with the word...
Oh, how does changing...
How. Okay, we got that.
How does changing the, maybe the,
Hold on, Sarah. Do you see a number where you're reading? What is the number we're looking for? The number on your assignment that corresponds to the title.
8.
8. So look right here. 8A, 8B. Right? I know that whatever gets written here should be up there. So I'm going to do it a little shorthand. And you'll have someone else in your group taking care of that part. And then it does kind of help us so we don't have to rewrite it too. Is this helping? Okay, good. You see why I kept pausing you and moving you back? Thank you. I bet you can probably figure that out. But now we got to move on to this table over here. There are other things missing in this graph. Getting a little harder as we go. There's 2 other big things that are missing. One of them's only missing from one graph. The other option for you guys in table 6 is missing from both graphs. Morgan. We don't have a key yet. Okay, is there a number that can help us perform that task of finding a key? Number 7, table 7. What number can help us make a key? 8A and 8B help us do our title. 9. Color each line in the graph and indicate their latitudes. That's making a key. That's a key. While over here is our graph titles. Graph titles, key. Awesome. Table 8, do you have any idea what is the last piece in the missing puzzle?
Is it the solar radiation?
Solar radiation. Why did you pick solar radiation?
Because, go ahead. It was in number 12.
Oh my gosh, look here. Sun angle, that's one of our graphs. Day lengths, that's another one of our dependent variables. Solar radiation. I know that it's not the easiest to try and figure out what is being represented by this graph, but I left you CC, and I know upstairs teachers would be really happy for you to come up with those literary terms for how you figure out missing information in a text. The key being text. There's 2 words that both start with C. Yes? Context clues. You can make connections with other things that you see around you. So both of you guys are correct. No, not whatever. How about that? This is solar radiation. Now for us, what is missing now? We have a label, but we don't know our units. Solar radiation is in watts per meters squared. Yeah, I would never have expected you to know that. Watts per meters squared. So what instrument that you could have on your house would this graph be very important for? Solar panels. She's on a roll. This would be really important for a solar panel. Is there any other graph that you may need to know how to be more efficient with your solar panels? Another graph that you have made. Yeah?
Like the daylight hour?
True, that's part of it. But more important is
Maybe the angles?
the angle. So you know how to position your solar panel. And you want your solar panel, compared to the sun, to be at a 90-degree angle. So there are a lot of places downtown where they have solar panels at the top of skyscrapers. Well, not really skyscrapers. High-rise buildings. And they move. They alternate. Whenever the sun moves, the solar panel moves as well, making them way more efficient. So now, who had number 8? Give us one of the boxes for number 8, whoever in your group had it. How does changing the latitude. Sarah. I can change my latitude. That's why it went first. I know that if I waited, I would change a lot of these other things. But if we're looking at our options of different variables, I'm trying to pick the one that is the easiest for me to change. Helpy? That's why I put it first, right here. Okay, keep going over here. Table 4, table 3. You can give us any of the boxes that are missing. Yes. Okay. KK? Not KKK, but going to KK. Okay. Okay. Any of the other boxes here, Trevor?
Affect the solar radiation.
Ooh. Hey, solar radiation. And on to the next table, table 4. Any of the missing pieces of these puzzles. We still have something for A. Someone other than Sarah, because she's already gone.
Are we changing the sun angle?
Sun angle. Okay, this one, not exactly sun angles. Look at your y-axis.
On the day length?
Day lengths, very good. How does changing the day lengths goes here?
No.
I can change the day lengths myself. So where would I put day lengths? Not in the first box.
What it affects?
What it affects. Good, right after affects. Day length. Excellent job fixing that there, Cassidy. Moving on over here. Somebody who hasn't spoken yet.
Also, we didn't finish.
A isn't done yet.
Throughout the year.
Throughout the year. Okay.
Also, it's the same for the bottom.
And also it's the same for the bottom. These guys right here. Somebody who hasn't spoken yet. We have a missing box. Missing line at your table, Mr.
Oh.
Could be you. Could be anybody at your table who hasn't spoken yet. Tate.
Yeah, she spoke.
Oh my. What affects day length?
The sun angle?
The sun at whoa.
No.
That's not what the graph shows. You are right that if the sun angle at noon has changed, you will also change your day lengths. That is true, but that's not what the graph is showing here.
Is it latitude?
Latitude, again,
We have a winner.
excellent, latitude. Same thing. For all the 3 graphs that you have seen from this assignment, either that you made or you have just observed, made, latitude is always the thing that you can change. Number 10. We've heard a lot from the 2 in the front. Max, were you doing 10, 11, 12? Okay. Do you have any information that could help us with 10, 11, or 12? Even if it's partial.
When latitude increases sun angle throughout the year,
Or we could do 9. Think you could color any of these in? Oh, he's going for it. He was like, I haven't done it yet, but I guess I can. I'm going to try it. Okay. So I've got some crayons here. I saw a couple of people find crayons on their desk. Obviously, I have lots and lots of them in the supply closet. We have oodles and noodles and hundreds and hundreds. Okay, Max. Start at 0, right? 0 is probably the easy one to start with. Do you have any idea in either graph which one would be 0? Stays mostly straight. So I'm going to make that kind of a blue. And I'm going to take the one that stays mostly straight. The amount of solar radiation at the equator is very similar throughout the year. There's a C word for it as well. Constant, consistent, those type of things. Max, excellent job. Keep going.
I have a question. For this purpose, is it okay if we just label them? Like we just
Yes,
put
you just put the numbers on there. That works too. Good. Max is off the hook. Okay, Materia. You could do anything. 9, 10, 11, 12. Put some colors in here. Any of the graphs. Help us answer some of these more extended questions. Feel free to pass to Ruby if you like. Pass to Ruby. Okay. Anything. 9, 10, Max just showed us that at 0 degrees, the amount of heat received at the equator really doesn't change that much. It has a flat line. Could we transfer that to the day length graph? Over here. Which line do you think is 0 degrees? Having trouble? It's all good. Moving on to these guys.
Okay, straight line.
Straight line. So what do you notice? These graphs have some similarities. Very good. Plus, there was another clue in this graph to tell you that this was going to be 0 degrees. The word equator was written in that graph. If you see the word equator, you always know it's going to be 0 degrees. Once again, we are using CC. Context clue. What do I see around me? How can I use that to help? Table 5. Who hasn't spoken yet? Or table 4, sorry. Who hasn't? Kenyon and Sydney. Okay. You can pick anything that's left. We're still labeling colors. We haven't done 10, 11, or 12. So Sydney or Kenyon, either one of you, help us out. You can. I would think it'd be easier to help us now as opposed to later.
Okay.
Sydney's going for it.
So I can do 11, right?
You can do 11, sure.
Alright. So the first blank would become longer, causing temperatures to get higher.
Okay. When latitude decreases, would that be towards the equator or the North Pole?
What?
So we're doing 11, right? So Sydney, I'm talking to Sydney and Sydney only. I know you guys get really excited sometimes. If your latitude is decreasing, is that going to be a bigger number or a smaller number?
Smaller.
Smaller number. Would that be more towards the equator or more towards the North Pole?
More towards the equator.
More towards the equator. Excellent. So here we are at 0 degrees. And what did we label for our day lengths? We pretty much
The equator.
get 12 in January, 12 in February, 12 in March, 12 in April, 12 in every single month of the year. So let's try this again. When latitude decreases, that means we're getting close to the equator. The day lengths throughout the year, 12, 12, 12, 12.
Stay the same.
Stay the same. Good. Are more, there's that C word again, consistent. Is it E-N or A-N?
I'm not the one that asked.
E-N-T, yes. Awesome. Got it right. First time. When latitude decreases, the day lengths through the year are more consistent because, and we can pass that on to table 6. Someone who hasn't spoke. You can finish this because. You can give us one of the lines. You can answer any of the other questions we have left. Have you already gone yet?
Oh, yeah.
Yeah, you have. Ezra, are you gone? Anything on here that you think you feel comfortable with sharing? We can do some of the lines, some of these question and answers.
12.
12, okay. Solar radiation, this graph up here, does not change very much throughout the year. What can you infer? What can you assume?
It's near the equator.
It's near the equator. Near equator. And for latitude, Ezra, we call that a low latitude. Thanks for allowing him time to come up with that answer. Lower latitude. That means it's going to be a smaller number. Good.
Hi. Oh, I guess I can color one maybe.
Oh, good. Okay, which one do you want to color? Just did 0.
30?
30, sure. Okay, so I'm going to make my 30 orange. I'm going to try and keep it consistent. Okay, now you notice that in both of these graphs, the 0 degrees was very straight, flat. Almost no slope at all. So what do you think 30 is going to be?
This one might go like above the 200.
Exactly. How does it slope compared to the other graphs? Or the other lines, I mean? Not as steep. So what's going to happen over here? I think mine might do.
It's gonna be the one that's like slightly like up. Is this one the one like above the 8 and below the
Slightly above the 8.
Yeah.
Now, it's hard to see what happens after the equinox. Am I going to go really high or stay close to the equator? I'm going to stay close to the equator. So you're starting to notice some similarities. Close to the equator, small latitude. Once again, not a lot of change in slope. Close to the equator, smaller latitude. Not only are we showing a difference in solar radiation and day length, we're also seeing a change in the shape of the graph. Which is going to help us a lot. You really want to ask something,
I have
yes?
a question.
Great job,
So
Hunter.
when you're doing like coordinates like on the Earth, do you do latitude first or longitude first?
Latitude comes first, always. Latitude influences your climate. Tropical, temperate, polar. Longitude really doesn't impact it all that much. I mean, it depends on if you have a big mountain range or something around you.
Okay.
But just latitude by itself has no effect on climate. Changing your latitude and only your latitude will change your climate.
Wait, you said longitude.
Longitude
Oh, okay.
by itself doesn't change your climate. Latitude, if you change it, will always affect your climate. Good. Who's next? Connor. Anything you want to fix, improve, answer.
For 13.
13. Oh my gosh, you're going to answer these questions. This is hardcore.
I said by changing latitude and location, the solar radiation would change throughout the year, and that it would increase towards the north and the south poles and decrease. It would increase the temperatures towards the. Wait, no, it would increase.
All right, let's stick with some formatting here. I'm going to help you out with some formatting. Latitude increases, and then you give us the second part.
Temperatures decrease.
But it's solar radiation here.
Right, and so the solar radiation increases as well.
Well, sometimes it increases.
Hasty.
Sometimes it's at very low amounts. Flat line, steep line.
Stays more consistent.
As your latitude increases, are you moving towards the equator or towards the poles?
You're moving towards poles.
You're moving towards the poles. So your solar radiation will
Stay more consistent.
0, consistent. 30, bigger number, less consistent.
It will increase.
Increase and decrease more or less. I don't know. Is it going to be a flat line or a steeper line if I have an increasing latitude? Steeper line. Are things going to be consistent or more extreme? More extreme. Latitude increases, more extreme changes. Now, would that work for this one too? If I increase my latitude, will I have more extreme changes? So we've answered both questions at the same time. We also need to be able to do the exact opposite. Lower latitudes mean less change in solar radiation, less change in day length hours. A little better, Samantha? And I know it's the increasing, decreasing. I know where that comes from. I do the same thing. I struggle with it myself. I have to, whoa, hold on a second. Increasing. Oh, that's going towards the North Pole. That's a bigger number. I struggle with that myself. Ruby, Matea.
It's kind of weird though because like.
You want to try one of the lines, maybe? We've done 2 of the lines. We've answered the question. Bigger number of latitude, more extreme changes, steeper slope. Either one of you guys, you can pick. We're trying to label a line. We're trying to put a color for a latitude to go with a steepness of slope. Okay. Struggling still? Okay.
She hasn't written yet.
All right. You could talk to us about 60 degrees. I'm going to make 60 degrees green. Which one of these 2 lines is 60 degrees? The one that has some sunlight in January, or the one that has no sunlight in January? Some sunlight in January. Thank you, Ruby. Good job. You're right. And I'm noticing that I have a slightly bigger number, and the slope of my line is getting a little bit steeper. Increasing latitude, increasing change, or slope. Raise your hand if this is starting to make sense at least a little bit for you guys. Okay, still struggling back there in the corner. Okay, we'll have to do another example. Ruby, you're off the hook. Good job. Yes, ma'am?
Okay, can I just say that, like, the rest of the coloring?
Yes, please.
We're going, like, one line by line. And,
Yes,
okay.
yes, please.
So, for 90, there's only, for 8A,
Yep,
there's only one last line, so it's clear that it's going to be the steepest one, because it's
They change
bigger line.
solar radiation
It's more steep
a lot
or more different.
more than the others. You see a greater difference.
Yeah.
I mean, they're 0. They don't get any sunlight at all for 6 months. That stinks. Okay, let's keep going.
Okay, so for 50, I said it was the one right under 30.
Right under 30. 8 hours.
Yeah,
And then right
it's the right above. 30
above.
again,
It has a slightly steeper slope,
but not too much.
but not too much. So we're talking, 50 degrees? Okay, yeah, we're fine.
Okay, and then 60 is the one right under 50 and a little above 50. That is under the 8. And then that leaves us with 70, which is the big giant slope.
I can just use my pencil for it. Beautiful. Here's 70. Here's 90. 0. 0. Awesome.
Good job.
Alrighty. Sydney, you've helped us, haven't you? Kenyon. Anything that's left? Sun angles. Latitude increases. Would that be towards the North Pole or the equator? Your latitude is getting bigger.
North Pole.
North Pole. Okay, so I put it here. North Pole to remind myself of where I'm going. Sun angles throughout the year. Which line's the North Pole up here? Which color? Orange, right here. That's the North Pole.
Red.
Red. Okay, yeah. It says here 90 degrees north for you to help. Okay. I'm a climber. How would you describe this? Really steep. So are they going to change a little or a lot?
A lot.
Okay. So now let's try 10. We'll start right there. At the North Pole.
Sun angle. Throughout the year. What did you increase? Decrease.
Can't say increase or decrease because all the others increase and decrease. Or you could say increase and decrease at a very can't say steep. There we go. Thank you. Throughout the year, change at an extreme rate. All right, so now we're open up to Omar. You help us, Omar? You help us? Causing temperatures to, if your solar radiation, the amount of heat you're getting from the sun, changes radically. What is that going to mean for your temperatures? They also change radically, causing temperatures to change dramatically. Because. Table 7.
Because the extreme rate.
Because solar radiation heats the planet. Okay. I would just change a planet to the ground.
Yeah.
Because the sun doesn't warm the air around us, which is hard. hard for us to think about. It's the ground that's actually warming our air. So the energy comes from the sun. It's got to warm the ground. And last but not least, what'd you just do? I liked it.
Oh, like the heat from the ground thing. That's all.
Do you remember what that process is called? Convection. Because, okay, we're going to go a little bit further here. There's a special type of radiation that is used for heat.
Infrared.
It's not infrared, it's infrared. Sorry.
Now, there's a lot of different ways of answering these questions. Lots of different ones. All right, moving on. Anybody at table 7? Keep us going. Anybody. Doesn't matter who. Even if you've gone before. When latitude decreases, the day lengths for the year are more consistent because table 7, that's you guys. We are trying to do this because. Megan? Okay, that's all right. Alex, you want to take that?
Because they're getting closer to the equator.
We need to use stuff from the graphs.
Got it. Okay.
Okay.
Here are more consistent.
Day lengths are more consistent because the
Latitude? No. Just slope is getting steep. Slope is not. Okay, I'm sorry. I don't know your point. Just the solar radiation
does not change.
does not change.
Does not change very much because solar radiation is consistent. Now, we can throw in all of those things like you're closer to the equator, you're never going to be pointed away from the sun for too long, your sun's always going to be high in the sky. I mean, we can throw a lot of things in there. There's a lot of options for it. So, anything else that we can infer about a place if your solar radiation does not change? Yes, you're near the equator. You're also going to have
Similar temperatures.
similar temperatures, consistent temperatures. We could even say consistent warm temperatures. Anything else? Trevor?
Consistent day lengths.
Consistent day lengths. Consistent temperatures, day lengths, and amounts of solar radiation. Alright. Yes, you are absolutely right that we need to be good with interpreting these graphs. Yes, we need to be able to connect those independent, dependent variables to project questions and x and y axes. And then, of course, a basic understanding of things we talk about during these presentations. Why is the equator always warm? I hope you would be able to answer a question like that. See you tomorrow. Bye-bye.
Okay.